Okay, in this video we're going to finish the notes for 2.1. So this homework assignment, I didn't give as a homework assignment. I gave it as an in-class notes taking, but we did not get to it in class, so I'm going to do it now for you. Okay, so describe how to sketch the fourth figure in the pattern. So what I'm going to do is I'm going to say, okay, figure 1 has, let me get out of that, has 2 segments. Figure 2 has 1, 2, 3, 4 segments. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8 segments. So you are doubling segments each time. So therefore, I could say that figure 4 will have 16 segments or sections. And what else can I say? And they will alternate in color, dark, light. Okay, so you don't need to necessarily draw it. It just said to describe how to sketch the fourth figure. Okay, so then this next one is also more patterns. Describe the pattern in the numbers. So 120, so write your numbers down, 60, and 30. And then they also want me to write the next 2 numbers in the pattern. So I'm missing 2 numbers. So to go from 120 to 60, I divide by 2. Does that also work here? If I divide 60 by 2, will I get 30? And the answer is yes, I will. So now I'm going to divide 30 by 2, and I get 15, and divide 15 by 2, and I'm going to get either 15 over 2 or 7.5. So describing the pattern, I would say that the pattern is divide by 2 each time, and write the next 2 numbers, and I've done that. So make sure with these that you answer all the questions. Okay, so if describe the pattern was the yellow, so let me not cross that out, so hang on, let me just back out of that. So if describe the pattern was underlined in yellow, here is describe the pattern. If write the next 2 numbers was a requirement also, which it is, here are the next 2 numbers. So now I know that I've answered all the questions. So let's go on to the next page. So this says, given the pattern of triangles below, make a conjecture. So what's a conjecture? A conjecture is a statement you can make after an observation. So make a conjecture about the number of segments in a similar diagram with 5 triangles. Okay, so if I have 1 triangle, I have 3 segments. If I have 2 triangles, I have 3, 4, 5 segments. If I have 3 triangles, I have 3, 4, 5, 6, 7 segments. So that means that if I have 4 triangles, so 4 triangles would yield 9 segments, following the pattern, increasing by 2 each time, and 5 triangles will yield 11 segments. Okay, let's read this question. Given the pattern, make a conjecture about the number of segments in a similar diagram with 5 triangles. Okay, so my conjecture is the pattern. When you start with a standalone triangle, you have 3. And then if you add them in this pattern, you're going to add 2 segments for each additional triangle. Okay, that's the pattern. Okay, we can draw it if you want, but I'm not going to do that right now, but you could draw it. Okay, so let me go down to the over to the next page of notes. So here we have numbers again. So it's all about patterns. Math is very much about patterns. Numbers such as 3, 11, 15, and 29 are odd numbers. Okay, so they're odd. Make and test a conjecture about the product of any two odd numbers. Okay, so I'm going to start low. How about 1 times 3? Product is the multiplication. That equals 3. How about 3 times 5? That equals 15. How about 7 times 5? That equals 35. So my conjecture is that the product of odd numbers is odd. That's my conjecture. Okay, and this is my test. So let's underline some things. Make a conjecture. So let me switch color here. So make a conjecture. So here's my conjecture. And then they want us to test it. So test is this. Here's my test. I took 2 odd numbers and I multiplied them together and got an odd number. Okay, if you find one counterexample, then the pattern does not hold. Okay, and that's what we're going to hit upon in this next question. It says find a counterexample to disprove the conjuncture. Okay, so here's our conjuncture. Supplementary angles are always adjacent. So I think about that and I say, okay, let me just draw supplementary angles. Supplementary angles add to 180. Okay, angle 1 and angle 2. So they are supplementary. And they are adjacent. Okay, so that's the conjecture that would have been made. I need to find a counterexample. So let me change my color. And let's think about a counterexample. Is there any reason why these supplementary angles have to be on the same line? And the answer is there is no reason whatsoever. What if we just separated these two? Okay, this is angle 2. This is angle 1. What if I say angle 2 plus angle 1 equals 180? So they are supplementary, so therefore, the 3 dots are therefore, they are supplementary, but they are not adjacent. Right? They're not sharing a common side and a common vertex. So that is your counter example. Okay, we have one more problem in these notes, so let's do that on the next page. So this is reading. So you have to read for context, okay? So figure out what this is all about. So it says, which conjecture, okay, so which observation can you make, or what statement can you make after looking at this information, could you make based on the graph? So the first thing I would do is look at the graph. The graph is of drama production participation. The years are 1984 to 2004. And it says number of dramas produced, production participants. So it's telling me that the participants are on the vertical axis and the years are on the horizontal axis. Okay, so let's read the first one. Could you say, based on looking at that graph, that participants have remained steady since 1984? Well, here's 84. If they were steady, then I would have a straight line like this. I do not have that straight line, so therefore I'm going to say that that's not true. I cannot make that conjecture. Okay, let's read B. The number of girls participating in a drama production exceed the number of boys. So I can't say that because there is no gender mentioned here. If they don't talk about gender, I can't talk about gender in my conjecture. Okay, look at C. The number of participants for West Side Story is over 50. Can't do that either. Okay, so West Side Story is not mentioned. So I can't draw that conclusion. I cannot make that conjecture. But now look at the last one. Participants have increased steadily since 1990. Okay, where's 1990? About here. And is that true? Has it continued to go up? And I would say that's a yes. So this is a yes. So that's what you can say. You can only say this, nothing else. Okay, so that ends the notes for this section. Make sure you have this written down in your notes package because there is a quiz coming up.